Hey everyone, finishing up this chapter one. I had a couple of questions on one of the homework problems, and just wanted to maybe go through that, make a quick video, and point out a few things for you, and maybe it'll help some other people as well. And let me do this and put this problem solved over here. Okay, this is problem number 96 on page 14, and it starts out and he gives us a table, and we've got three resistors. Okay, we got resistor A, B, and C, and A has a resistance of 100 ohms, B is 50, and C is 300. A has a power of 24 watts, B is 75 watts, and C is 40 watts. Okay, so he says in the directions, using A as a base, determine the per unit values of the resistance, the power, and voltage for resistors B and C. All right, so what that means, and I'm not sure exactly, it's perfectly clear in the directions, but what that means is resistor A is designated as the base, okay? So that means the base resistance is 100 ohms, and it means that the base power is 24 watts. All right, now, so we write that down. Now, only problem, he says, I also want to know what the voltage rating is. So I need a base voltage. These go back to the types of problems that were worked in section 111. And so what we're going to need to do, is we're going to have to derive the base voltage using the two things that we're given, which is resistance and power. Okay, we have three power formulas. The most familiar one is power is equal to voltage times current. And also have the, let's see if I can actually write here. Oh, I can write. I didn't know that with this. And the other one is power is equal to current squared times resistance. Okay, so and then there's two, and then the third one is the one that we're going to use, which is power is equal to the voltage squared divided by the resistance. Okay, we know the power and we know the resistance. All right, so we can solve for E, or voltage, and get the base, that we can get the base voltage that way. So we know that resistor A is the base, so there's 24 watts. The voltage we don't know, we're going to derive, and the base resistance is 100 ohms. We solve this for E squared. We solve this for E squared, and we've come up with a voltage of 48.99. We designate that now as our base voltage. So if I were going back to this chart, I could add another column here, right? And I could call that voltage, and we would know that the base voltage is this, okay, this is not looking good. This base voltage is 48.99 volts, okay? So going back to this, now to do what he told us to do, we want to create a per unit table. Okay, well, again, three resistors. The base is resistor A for everything. So it's all a series of ones, right? It is the base unit. So the base resistance for A is 1. The base power for A is 1. The base voltage per unit for A is 1. And now we're going to compare everything to that base. So we go, and for B, for B, we're going to say it's 50 divided by the base of 100. We get 0.5. We put that there. We get 75 watts divided by the base of 24, and we get 3.13. We put it there. And now we use these per unit values, and we can do all our calculations. We can do all our calculations here in per unit values, or we could have used the actual values. It doesn't really matter, but plugging this in, going to this part of the formula here, right, where we're multiplying, we're solved for E squared, and we're multiplying the resistance times the power, going back to that. Well, for B, it's 0.5 times the per unit power, right, 0.5, 3.13. Multiply that out, take the square root, I get 1.25. It's the per unit for voltage. Same thing for C. you know, I have the base of 100. It's a 300 ohm resistor. Its per unit value is 3. Its per unit value of power is 1.67. Again, going back to this formula, I say per unit 3 times per unit 1.67. Get that answer, take the square root of it, and I get 2.24. Okay, so that's how that problem works, and you know it's a really good problem, proving that you know, being able to do that proves that we've really got this concept of per unit values down. Okay, let me stop this, and I'll be back in touch soon.